continue our topic on dealing with special functions. This one is a piecewise function. And this particular graph, all right, this is on chapter 2, section 6.
Pizza count.
Pizza count. Sorry, I had to pause that. Today was pizza day, so we had to get a pizza count. You know, 'cause we have pizza days at our school, don't we?
Yeah.
Yeah, that's right. That's why you should come to East Texas Charter. Get pizza on certain Fridays. That's right. Free advertising right now. Free
Oh,
advertising.
yeah.
That's right. Hey, we'll jump up from like 10 to like 11.
Yeah.
All right. Talking about pizza. Now, this one is not that bad of a piecewise function because technically we only have to graph 2 pieces. Now I'm thinking of pizza right now.
Yeah.
I'm thinking of pizza right now. So right now, here's the first one. Write this down. F of x. No, we're not going to graph pizza. All right. That's going to be in conic sections when we're dealing with circles. All right. That'll be next year. All right. Freak out. All right. So. Huge pizza. So the first function we're going to graph is f of x equals x plus 2, but we're only graph the portion where x is less than or equal to negative 2. Now when you guys are doing this, it's not difficult. All you got to realize is this right here is the same as y equals x plus 2, which is in the form of y equals mx plus b. So you should be able to recognize that it has a slope and it has a y-intercept. Try not to slide too much there. Right? So, what is the slope of this line? Very good. What is the y-intercept? That's right, it's 2. I agree, it is totally 2. Good job, man. All right. Now, what we're going to do is we're going to graph this line. We're going to graph the y-intercept. I'm going to put a point. Now, do not use pen, people. Always use pencil. All right? I'm going to go up 1 and over 1 and put a point. Then I'm just going to continue my pattern, everybody. Continuing the pattern of a slope of 1. So if you go up 1 and over 1, you can still go what? Down 1 and over 1 to the left as well. So right now I'm just plotting points. There's all the points right there, integers, that you could plot for the slope of 1 and a y-intercept of 2. Now, I'm gonna connect all those points. You're right. Hold on. We're getting to the butt. Just a second. All right.
Nice.
All the way. That's my whole line. If I were to graph it, or I'm not allowed to graph the whole line. Sadly, because this says I can only go where what? X is less than or equal to a negative 2. So let me get my eraser here. What's the, don't tell me the y value. What's the x value right here? Nope, 1.
Wait, what? Where?
The x value right here is a 1.
I thought you
I know, I thought I was thinking something else. Right now, so that I can't graph that. What's the x value right here? 0. How about there? How about there? Yay! We can plot this point right here because that is technically equal to a negative 2, but I'm only allowed to graph all the other points that are less than or equal to a negative 2. So that right there is your piece. That's why it's called a piecewise function. All right? The blue portion has been graphed. Now we're moving on to the magenta portion, which is f of x equals 3x if and only if x is greater than a negative 2. Now once again, blue, even though I'm writing magenta, I'm going to say in blue, this is in the form of y equals mx plus b. Could anybody tell me what the slope is of this? 3. What about the y-intercept? 0. Very good. So we have to make a line that has a slope of 3 with the y-intercept at 0. So here's my y-intercept. Right there at 0. Now how do we do a slope of 3? We got to go what? Up 3 and over 1. Oh, we're out of room. So we got to go down 3 and over 1. And go down 3 and over 1. And then I'm going to draw the line So this would be the line right here. That would be the line. But wait, there's more. We can't draw that whole line because technically we can only do it where x is what? Greater than -2. So right here, is this greater than -2?
Yep.
Yes. This? This?
Yes.
Yes, it is. It's -1. That's greater than the -2. How about this right here?
No.
Well, it is open.
So right here, so guess what we got to do? We got to put an open dot right there. Gosh. So right here, I'm going to put an open circle, which means I'm not including the -2. You getting all this down, Jace? Because you're looking super excited today. Good. Just trying to get it all. Okay, once you get it all in your head, get it down on your paper too. All right? So here we go. This right here is both of your piecewise functions. They're both pieces together, and that makes your answer. All right? We're done with the graph. That's it.
Well, that was easy.
Not too bad. Now, I realize the screenshot does not have the word range, so I'm going to add the word range in a semi-straight line. Now the domain, all right? Over here, the domain is going over here to -infinity, but it goes all the way over to a 2.
-2.
Oh, you're right, -2. All right? And even though -2 is not being plotted here, it is being plotted here. And then all the numbers that are greater than a -2 are being plotted.
Oh.
So you're right, guys. All real numbers are being plotted. Okay? All real numbers. Now the range, whenever you guys have a line going down and a line going up and they cross over each other, you know that all real numbers are being plotted for the y values too. So you see how this is like going down to -infinity, also known as, we'll call it gains. Okay? And then going up to positive infinity, that's kind of called it pattern. Right? So if they cross over, then we know all real numbers. I'm trying to keep PG-13. All right. So the domain is all real numbers. The range is all real numbers. Those are both your pieces that are graphed. That's what you're trying to do on your last problem. Try to do number 12 on your own without my assistance. Good luck.